JAMB 2014, we have an object of mass 20 kg is released from a height of 10 meters above the ground level. Its kinetic energy just before it hits the ground is what? So for us to get a solution to this question, we need to understand something. That whenever an object falls to the ground from a certain height, at its maximum height, it possesses a potential energy which is given as mgh. While the kinetic energy at that same maximum height is equal to what? 0. Why? Because kinetic energy depends on velocity, and at its maximum height, velocity is 0. So kinetic energy is what? 0. So as this object falls to the ground, its velocity starts increasing from 0. Because of that, the kinetic energy will start increasing. While the height decreases, potential energy is what? Decreasing. So the energy, which is purely potential here, is now being transformed into kinetic energy as the object falls. So before the object hits the ground, the entire potential energy will be transformed into what? Kinetic energy. So at the ground level, the potential energy becomes 0, while the kinetic energy becomes equals to what? 1 over 2 mv squared. So before it hits the ground, the entire energy transforms to potential to kinetic energy. In other words, if it possesses a potential energy of say 500 joules here, by the time it hits the ground, or before it hits the ground, the entire potential energy will be transformed to what? Kinetic energy. So this kinetic energy of 1 over 2 mv squared will become the same value as the potential energy at the maximum height. So for us to solve this problem, so we have to now say that the kinetic energy before it hits the ground will be equal to what? The potential energy at its maximum height, and that is given as mgh. Therefore, we have that this will be equal to the mass, which is 20, times acceleration due to gravity, which is 10. No, it's constant, 10, times the height, 10, and that gives us a 2000 joules. So the kinetic energy just before it hits the ground is what? 2000 joules, and this is our answer. I trust you understand. Okay, let us look at another problem from JAMB 1999. This question is similar to the previous question or problem I solved, JAMB 2014. But please, care should be taken while solving this kind of problem, because the approach is not the same as the previous one. That is because the question is not exactly the same as that one. So now what do we do here? Having that the object is thrown vertically upward from a tower 10 meter high, it is totally different from saying that the object falls from a height of 10 meter high. So I'm going to show us two ways we can solve this. Let me divide our board here. So I'm going to use method 1 here, then method 2 here. Now in method 1, we can use the idea that while the object is falling, the potential energy at its maximum height is equal to the kinetic energy just before it hits the ground. So the potential energy is equal to kinetic energy, as I explained in the previous problem we solved. So now, how do we then get That kinetic energy, so potential energy at its maximum height, then we need to get the maximum height first. Because when you throw it off from a tower, it needs to get to a certain height before it will start falling down. Because of that, we are going to get the height attained by the stone before it starts falling, or sorry, by the object before it starts falling. So we use the fact that at maximum height, its velocity is 0 meter per second. Are you with me? That is its final velocity is that. Then initial velocity u is already 10 meter per second. That is the velocity of with which it was thrown up. Then g is 10 meter per second squared as given there. Then height is unknown. What height are we looking for? The height it attained when it was released from the top of the tower. So using v squared equal to u squared minus 2gh. I know we are all familiar with this equation of motion. We are using minus there because it's motion, upward motion against gravity. So v being 0 here is equal to 0 squared is 10 squared minus 2 times 10 h. So 0 here is 100 minus 20 h. So that means 20 h is equals to what? 100. So h is equals to what? 100 h. Let's remove this. H is equals to 100 over 20, which is 5 meter. So the object attained a height of 5 meter above the ground before above the top of the tower before it starts falling. So total height above the ground is 5 plus 10. That is the height it attained from the top of the tower plus the 10 meter, which is the height of the tower above the ground. And that gives us a total of what? 15 meter. Now, we can now use the fact that the potential energy from the maximum at the maximum height is equal to the kinetic energy before it hits the ground. So that gives us our PE or KE before hitting the ground to be equals to PE at its maximum height, which is mgh. And that is 0.1 times 10 times the height now, which is what? 15 we have gotten there. And that gives us what? 15 joules here. So we have 15 joules. That is method 1. Then let's look at the second method, method 2. So let's look at the second method. In the second method, we are going to use the fact that mechanical energy is equals to kinetic energy plus what? Potential energy. The total mechanical energy possessed by the object as a force is equal to potential energy plus what? Kinetic energy. Now, since the object was released with an initial velocity of what? 10 meter per second. So we are going to have that this is 1 over 2 mv squared plus what? mgh. So, and that will be equal to 1 over 2 times 0.1 times 10 squared, that is velocity, plus 0.1 times 10 times 10, that is the height above the ground. So, and that will give us here is 1 over 2 times 0. This multiply this is 10. Then plus the whole of this will give us 10. So this cancels this. That gives us 5. We have 5 plus 10, which is equals to 15 joules. And that gives us our answer. Thank you very much. God bless you.